Hello friends, welcome to wisdomjobs.com. My name is Ashok. Today in this video I am going to discuss a topic on we have been dealing with some concepts. So our concept today is the concept related to heat transfer, that is general and one-dimensional heat conduction equation with special forms. As a part of science and engineering module, we are dealing with this variety of concepts. So we have chosen this. And what is this topic? Immediately after seeing this title, engineering students could easily connect it to this, particularly this mechanical engineering students. So the other students, any level of education, be it school level or any level, +1, +2, whatever may be the level of your education, you could know because it is dealing with this part of heat transfer. I mean, heat transfer part is essential in almost all the engineering applications. That thing we know. Okay. So basic definition of conduction. I mean, you know the definition. I mean, you know this word basically. Every student knows this. So what are the various modes of heat transfer? We know conduction, convection, and radiation. Of which conduction, heat conduction. So we must generalize that conduction in order to apply it to various applications, engineering applications. Okay, so day to day engineering applications or day to day applications, whatever may be the application, we need to generalize an equation such that it will be useful for understanding that particular application. In the sense, we have to understand, make this physical thing into a mathematical form. I mean, we need to convert that whatever the physical form of problem we have, means heat transfer problem we have, we need to convert it into a mathematical form. So that mathematical form, a generalized form, that is particularly to this conduction we will be studying. So that general form we will be seeing initially. Later on we will be seeing one dimensional, because most of the applications it will be easy to simplify it to one dimensional and study. Okay, although in general cases not upon approximation, in generally in all the three directions, all the three spatial directions, so we have the change in, means heat will be transferred, but sometimes based on the problem, based on the requirement, so we will be approximating it to, we will reduce the dimensions. So most of the cases in this particular engineering heat transfer study, you do your BTech courses are coming to this elementary level, I mean school level, so you will be studying only this one dimensional thing, isn't it? So basic definitions you study at the school level anyway. So that thing we will be studying one dimensional, which is very important, because upon approximation, suitable approximation, so we will be using most of the cases this one dimensional. That's why these two are very important, generalized thing and one dimensional thing. So coming to the special forms, in the sense, so this is also one type of means based on the special situation, any specific situations, so we need to convert, we need to simplify these expressions to certain forms. Okay, so we will be seeing that, and we will try to understand the importance of those equations also. So in order to understand all these things, means a basic idea of all the heat conduction equation related things, so please watch the video till the end, because every point is important in this. So there are certain videos made not exclusively discussed in this video. There will be some concepts will be covered in other videos also, like I would say thermal diffusivity, that will be discussed in this another video, because every concept we need to understand clearly. So all the things, all the concepts we cannot put in a video. So this is like comprehension of this heat conduction equation related things. Okay, so I hope we are giving the variety of videos for you, all the modules, whatever the module required. Just go through our playlist wisdomjobs.com, so you could find various modules which would satisfy your I mean academic examinations or your competitive examinations, which would be very much useful, isn't it? So don't forget to subscribe. If you haven't subscribed yet, just subscribe, because we have been doing variety of videos. You will be getting the notifications for them, and just watch this video throughout, because you will be having definitely a guarantee that you will be enjoying this video. Enjoying this means some people enjoy the knowledge, means improving their knowledge, they just enjoy. Okay, so you'll definitely enjoy this video, and don't forget to like if you really like the video at the end. Okay, just subscribe and we will follow. So let us see what we have. Let us see our objective of this. Means just to put whatever I discussed while I showed you this title. So the same thing. We want to understand what is this basic heat conduction equation and their special forms. Based on that, we will be first we will try to understand that, then we simplify it to one dimension. So that is the intention of this video. Basically, I want to keep it short so that you will have a basic idea. So we will not dive deep into this. Rather, so when and where it is necessary, I would explain anyway. Those I'll try to explain as much as possible. Okay. So mostly I try to put these figures in this, so that you will be easily appealing to everyone who is watching this. Okay. So I hope you will be sticking on to this. Don't miss this slides, because so every slide is important. So let us move ahead with this discussion. So firstly, we want to discuss, so based on this general heat conduction, as I already while introducing this topic, I told you that, so in all the spatial coordinates we want to discuss how the heat is flowing, as well as in the temperature, heat is flowing, heat transfer rate will be changing with respect to it. It also changes in the sense, it also depends on time, isn't it? So all the spatial coordinates and time. And you could see here this rectangular, cylindrical and spherical coordinates, basic coordinates. So what are the popular coordinates? Prime coordinates. Prime coordinates are the only coordinates we always deal with is rectangular, cylindrical and spherical, isn't it? So in all the three coordinates, suppose if you are working on the analysis of a cylindrical pipe, okay, then we require the equation corresponding based on this cylindrical coordinates, isn't it? So that is the only thing why we are doing it various coordinates, because each problem is applicable to certain it will be appropriated to certain application, isn't it? So what are the coordinates here? So why did I give this T here? Temperature. Temperature is pertaining to this all the spatial coordinates, that is all the three dimensions, and fourth dimension is our time. Okay, so with respect to time also, how the temperature is changing. In the sense, this shows you that we are identifying what is the temperature field, because if you know the basics, if you come from the basics of heat transfer, the heat transfer is based on the basic the goal or aim of understanding this heat transfer is to understand the temperature field. Okay, how the temperature is being distributed, and also based on that we will be calculating how heat is being transferred, isn't it? So that is the main approach, main goal of this subject, heat transfer. So for that, what we require initially, temperature field. So this implies that temperature field means across these coordinates x, y, z, all the three coordinates. Similarly, those x, y, z are analogous to this cylindrical coordinates, analogous in the sense three dimensions. In cylindrical we have three dimensions, that is r, phi and z. So one azimuth angle phi. Then spherical we have one radius and two angles, one elevation angle and one azimuthal angle. Okay, so what is that those things? Okay, this is time is anyway, T is time. Okay, so how the temperature is being distributed in the spatial coordinates and also with respect to time. So the points indicate that. Okay, our intention lies in this point. So we will be discussing general equation based on these coordinates. Okay, so you could see all the coordinate systems now, all the three coordinate systems here, and we are indicating a point, we are describing a point in all the coordinate systems. Okay, so how each point is described in each coordinate system, you can see here. Okay, the first point in the Cartesian coordinates will be described by three lengths or three distances, whereas the point in cylindrical coordinates is described by radius and one rotation angle. Okay, so that is azimuth angle anyway. You can see here angle with respect to a reference horizontal. Okay, so and then another distance, in a vertical distance. Okay, so which is corresponding to this height of the cylinder. Then in the sphere, if you see, the point is described by radius and two angles there. So if you want to carefully observe here, just carefully observe here. So the radius initially is being inclined with reference. So we are referring to this vertical as this particular, in this case we are referring this vertical to be z. So with respect to z, what is the inclination of this radius? Okay, so usually this reference vertical we will be doing 180 degrees, means you will be doing this 180 degrees anyway. So that is the total angle, and once you get 180 degrees, what you get? You get a semicircle. So after you get semicircle, just sweep it through one angle. Okay, that is with respect to horizontal. You sweep it. Okay, so that horizontal angle is nothing but this angle, and you call it as azimuth angle, isn't it? So with respect to this azimuth angle, you will be sweeping this 360 degrees. You will be getting a sphere. So that is why these coordinates are taken. So if you understand this, it is easy to understand this one also. In cylindrical, just now observe what you have initially. So we have taken a radius, and radius is swept through 360 degrees. Radius is swept through 360 degrees. We will be getting a circle, base circle, and extrude that base circle through height in z direction. In this direction, if you extrude this circle, so you will be getting this cylinder, isn't it? So what are the dimensions lying in that? Initially we require radius, then radius is swept through, that is swept through 360 degrees to make a circle. That circle is swept in z direction to get the cylinder. So what are the dimensions we require? Radius, that angle, azimuth angle, and this vertical distance, that is height in the cylinder. So this is how we can compare this, and you can understand this. Okay, so I hope you understood how do we locate this in. So initially radius is inclined with reference vertical, that is theta. Then whatever you getting this semicircle is swept through an angle called solid angle, that is azimuth angle. That angle is phi. And basically initially what we have taken, that basic dimension is r. So that r is rotated, means in both the directions with respect to reference vertical, with respect to this reference horizontal. Okay, so that is how you will get that. So that is why you have got this what you call that coordinates, isn't it? So this is the basic thing in this. Okay, so if you see, so we will be understanding, we will be applying this with respect to the general heat conduction equation. Okay, so here if you could see a part of an element of that coordinate is taken, I mean whatever you have observed in the first slide, an element of that is taken, and we will be trying to analyze while we get through this slide anyway. If you see the next one, cylindrical coordinates, a part of this will be taken, a volume element, a small element of this will be taken, and we will be trying to understand like this, and we will be seeing what is the general equation. Okay, and then similar to this both the things, Cartesian, cylindrical, we will be seeing spherical coordinate element also, that spherical element, and we will take that and we will try to understand. So only the basic idea. Okay, so let us see first what are the terms involved, means what is the significance of various terminology we use. I mean in order to approach towards this general heat conduction equation, we must have basic knowledge of all these things we are going to discuss now. Okay, so let us see. So what is given here? Steady versus transient heat transfer. What do you mean by steady, and what do you mean by transient? Obviously transient is nothing but which depends on, transient is with respect to time. If there is a change with respect to time, change in the temperature basically. Okay, if you could see here, transient here given, so and even time is also given. So just for reference we have taken this time at 9 am, about 2 hours time. So if there is a change in temperature, you could see here how this initial temperature is changing, means the first side And you all know basic, means I am presuming the basic things you know. That is, heat flows from higher temperature to lower temperature. So here 15 degrees to 7 degrees. Now over a period of time, these temperatures have changed now. So 15 has reduced to 12, means let me say change it to 12, then 7 is changed to 5. Means over a period of time, okay, it is temperature is dependent on time now. So if the temperature is changed with respect to time, so that state is called as transient state. Okay, so that is another approach. Okay, so we need to consider. Sometimes in some cases we can approximate this case. We can not neglect, we can ignore this case. Okay, so that depends on application. That depends on our problem, our analysis we are intended to do. Anyway, so this is transient. If you consider steady, unlike this, if the temperature is not dependent on time, so steady state in the sense, so whatever the temperature you have taken initially, the same thing will remain here even after this time. Means with the change in time, how this is happening? With the change in the time, there is no change in temperature. This is equal. Even here also it is equal. So if there is no change in temperature with respect to time, it is called as steady state, isn't it? So this is one thing you need to remember. Next thing you need to remember is what is this heat generation? Okay, this is also one important point here. So these all things will be covered, will be useful to understand general heat conduction equation. What do you mean by heat generation? Okay, so you got to see, suppose suppose iron box you have. So how do you use that? So after you supply this electricity, some resisting element is present inside. So that resisting element will offer resistance to the flow of electricity. Because of that, heat will be generated. So you know that basic formula for that is I square R T. That is what is heat generated due to the flow of this current, okay, electricity. So this is the basic formula. I don't go much deep into this, but you might have got some idea now. So due to the resistance heating in electrical wires, okay, means whenever in certain application, okay, you got to see these electrical wires and this fuel rods in nuclear reactions and chemical reactions. And I think I should explain something about chemical reactions so that you will get a better idea. Suppose in a process which is already at a certain temperature, at elevated temperature, or at some lower temperatures, sub-zero temperatures, whatever. So if you are operating, certain processing plant is working on, means some heat exchangers are working on. So in that, if you mix up some chemicals, okay, some reactions has to be done. So some reactions tend to be exothermic, some reactions tend to be endothermic. Means you know that basics of that exothermic and endothermic. Means it indicates that some heat is being generated or some heat is being absorbed. Let us take the case of heat is being generated. So means our basic thing is, initially we are working at a certain temperature, and that is placed, that element, whatever heat exchanger is placed at certain ambience. So that certain ambience and the inside temperature will be that is our primary concern. But we cannot ignore what is happening with the chemical reaction. So in the chemical reaction, if there is, due to this exothermic nature of that reaction, so if some heat is generated, we cannot ignore that. We need to take the consideration of that heat also. So in such cases, even in this means our design should be based on, our design of those heat exchangers should be based on all this approach. So basic this conduction approach. Nuclear reactions, if you see, so if you don't consider that whatever the nuclear reactions, that fission, fusion, heat will be generated, that heat generated must be taken into consideration, because if you don't design according to without taking the consideration of that heat generation, so obviously so these reactors may the fuel rods may burn out, isn't it? So those things happen here. Even resisting heating also, if you don't consider that the other topic means I have already discussed this critical radius of insulation. Just try to watch it. Basics of that critical radius of insulation I have discussed, and this is corresponding something you can understand with these electrical wires. In our playlist you can observe that video. Okay, so why resistance heating in electrical wires is important here. Means for all these things, means whenever you have this application, heat generation is important. You can easily understand that the heat generation basically is a volumetric phenomenon. Whenever heat generation is given, they will give you with respect to this volume, the basic unit of that is watts per meter cube. And so in this, if you see this G dot, or some people may put it as QG. Okay, notations may be various ways, the notations may be, but QG or G, just G. This unit this is nothing but that heat generation density. Okay, that heat density, heat generated, watt per meter cube. So when we consider usually the volume of that element in which heat is being generated, so that may not be constant. So for that, this elemental volume is taken. Otherwise, if you approximate that volume to be constant, so we can write this expression to be like this also, isn't it? And what will be the unit of this? Watts. Unit of this is watts. Okay. So let us move. You understood. I hope you understood about this heat generation. Let us move to the next slide now. So let us see another thing we need to understand before getting into general heat conduction is multidimensional heat transfer. So what is this approach basically? Multidimensional in the sense, if you consider the heat transfer in all the three directions, that is anyway three-dimensional heat transfer. Multidimensional in the sense, if more than one dimension if you are considering, that is two-dimensional, or again this three-dimensional also. Both the things will come under this multidimensional. Also this considering the time also. Okay. So what is the purpose of why we try to understand this? Means during the discussion of this introduction of this title also, I have explained this, that most of the cases we have in general we have to consider three dimension only, but based on suitable approximations we get to understand, we get to reduce the complexity of the problem, considering approaching towards two-dimensional or one-dimensional analysis. Like simple examples will simple considerations will make you understand why we approach towards this multidimensional analysis. Suppose multidimensional could be any two-dimensional, three-dimensional. Even some cases, if you see this window of this house, okay, our heat transfer mostly through this window. The other two direction through the wall, whatever the heat seeps in, that amount is negligible when the heat you consider out of the window, coming out of the window. So the other two direction you can neglect it. So that's why this can be approximated to a one-dimensional case. So if I want to, there are many examples though. If I want to give you another example, so this iron box. So when you press your clothes, so you could have observed that. So how the heat is flowing. That whatever the metal plate you have, that heated plate and the iron box, that can be considered, means the heat flowing through that plate can be considered as one dimensional, isn't it? Then you consider this one, two-dimensional heat transfer here. So this you can understand. Okay, so this is a long rectangular bar. Long rectangular bar. So when compared to this, the other two dimensions, width and the breadth, and width and the depth here. Okay, so considering these two dimensions, this dimension is so large. This dimension is so large. So when you compare, means the rate of heat transfer when compared to this direction, the other two direction you can easily observe. Means heat will be diffused fastly in the other two direction. Means which is the dominant sides here? The only two dimensions are dominant in this when compared to this length. Okay, so means we are just approximating this particular element to be of two-dimensional case. Heat is transferred in two dimensions, because it would means that is with suitable approximation we will be solving this. Okay, so that is the importance of basic three-dimensional. General heat conduction is necessary, but we need to approximate the things based on the necessity, based on the problem we get, I mean based on the type of analysis. Okay, so if you consider all the three dimensions, okay, so one important term, another term is isotherm. You need to understand what do you mean by isotherm. So basically we all know, okay, let me put initially for 2 dimensions, then we get into this 3-dimensional thing. In 2 dimension, if I want to put, okay, just consider here heat is being flowing in this direction, okay, or let me put in this direction here. Let me take case of simple case here. Suppose we have a frame like this, okay, so heat is being transferred. Just take a section here, just take a section. Let me draw this section here again. Okay, so how the heat is flowing here, okay, let me take the temperature here. Heat is being flowing in this direction, heat is flowing in this direction. So provided the temperature field will be perpendicular, the temperature field will be temperature profiles, whatever the profiles we have, that lines will be like this. Those means I wanted to take that name, but those lines are called as isotherms. Means whenever you take this line, on this line everywhere the temperature is same, means through this heat is being flowing. So whatever the heat we have, heat is flowing in this direction. Okay, so these are isotherms, and these are heat flow lines. These are heat flow lines. So you could understand here. See, let me draw with another color here. So these are heat flow lines, and the other lines are called isotherms. So from this you could understand, so what is the direction basically, okay, how the heat flows. You could see now with that analysis, I mean with that short discussion, you could understand this one also. In 3 dimensions, what is happening here? So there will be, due to this, suppose heat is flowing in a particular direction, you can consider them as vectors. So all the x direction, y direction, z direction, we have heat components. So all together we have a net effect, okay, or the other way if you put, so heat is flowing in a particular direction, obviously means it is a vector. Basically it can be based on basic vector analysis, you know, means they can be made into components. Okay, if you see Qn, that is the final, I mean the actual heat transfer flowing in a particular direction. So how the direction is, it is normal to this curve. This curve I call it as isotherm. Means this isotherm to, suppose at a particular distance we have another isotherm here. Suppose we have 100 degrees Celsius here, and this is 70 degrees Celsius. Means heat is flowing in this direction, in the sense some higher temperature to lower temperature it is flowing, and whatever the curve you take or surface you take, that is called as isotherm. The temperature will be constant here, means this temperature to this temperature heat is flowing. And if you split this, means if you want to make it into components, being a vector, now we can make it into components. So being a vector here, you can write it as qx I bar, then qy j bar, qy j cap, then plus qz k cap. Okay, these components we can put it into. Means I just want to give you the basics of this 1-dimensional, 2-dimensional and 3-dimensional thing. Okay, that's what. So I hope you got basic of this. I don't want to get deep into this. So basic idea we require. So we are our intention of this video is that. So friends, this was the video. I mean in this video, as a part of whole concept of this general heat conduction equation, so we are making it into parts. So this is the first part you have seen. So just we have given you some basics of some basics you need to get along, so you need to understand. So in order to understand the other part of this concept, that is general heat conduction equation derivation. Okay, so what you have in this rectangular or Cartesian coordinates, cylindrical coordinates and spherical coordinates, also one dimensional equation. So all these things we'll try to understand in our parts of this concept. Anyway, the whole concept is covered into parts now. So this is the first part of this video. Hope you enjoyed this video. So try to subscribe our channel in order to get the notifications of other videos also, because these concepts we are covering, we are made into parts, and also randomly we are making various topics. We are covering various topics, and if you have any suggestions, you can comment in our comment box. If you need any particular topic, we'll make the videos regarding that. So hope you enjoyed this video, and this is not the end. It is continued in the another video, so try to watch that video also, means the other videos, other parts of this concept. So try to understand whole concept through and watching all these videos. Okay, thank you so much for watching. See you. Bye.